Learning Objective D wants us to interpret row and percent column tables. So the first thing you want to know is which one are you dealing with. Now on our slide here, it actually says percent or column percent and row percent. Typically they don't tell you, you just actually have to look at it. So again, we have there our Titanic data that we're used to looking at. And if you look at this, they're saying it's columns. So if you look at the column here for first class, we can tell it's a column percent table because 62 plus 38 is 100. Again, if you look at the crew, you'll see 24 and 76 is 100. So the totals were done by percentages. How they got the total, for example, of 24%, they did 212 divided by 885. Now the second one here is a row percent, so let me show you. If we look at the row, there's 711 people in total in this row. How did they get 30%? Well, 212 divided by 711. They did that for all of these. If you add up all four percentages, it will be 100%. So the question here, what does the 17% represent in the table, which is right here? That percent is of the people that survived, what percent was in second class. So here's an example of where they're not going to tell you if it's a row or column percent table. Here we have fifth grade students in a school. They were surveyed about their favorite book series. Here's what they did. The two variables they're using are gender and then the book that you liked. So we have here the boys and what percent liked Harry Potter and so forth. So the first thing is this a column or a row percent table? Well, look at it. If you add up these columns, does that equal 100%? It doesn't, so this is a row table. So if you add this, that's 100%. So this question says, what does the 23% represent? So 23% represents, of all the boys, it's the percent that liked Lemony Snicket. Okay, part B, which is larger, the number of boys who preferred Animorphs or the number of girls who preferred Lemony Snicket. So the boys in Animorphs is right here. The girls in Lemony Snicket is right here. Now the question is which is larger, and they're talking the numbers. These are percentages. So we have to figure out how we can get a number count. As of now, there's not enough information to figure this question out. I need to know how many boys there were in total, and I need to know how many girls there were in total to figure out a count. So we can't do part B. So knowing that, they're now going to give us more information. Okay, what if there were 500 boys and 400 girls? So for the Animorphs and for Lemony Snicket, we can compute that. So for the boys, I'm just going to say there were 500 boys. I want 15% of that. You guys, 15% of means multiply. So if you multiply that, that's 75 boys. Now for the girls, we're going to do the same thing. There were 400 girls. 28% of them preferred Lemony Snicket. That's 112. So the answer here is clearly going to be the more girls preferred their book. Let's look at the information about the kids reading the books again. But this time, instead of saying that there were 500 and 400 girls, let's just say all we know is that 60% of the people we asked were boys and 40% of the people we asked were girls. We're not sure how many that was. And we had the same responses for which percent of books that they read. And if the question was this, what percent of all students read the Harry Potter book? Your eyes are obviously going to go towards the Harry Potter column, and you're going to want to add up these two percentages, which as of now would be 93%, and then think about how to average that out. Most times for averaging, people will add up the two, and then you will actually go ahead and divide by 2 to get the answer. And when you do this, what you get would be 46.5%. Now, I have to tell you, this is actually the wrong way to do this. The only way you would be able to do this approach by adding the 2 and dividing by 2 to average is if these are both equally balanced at 50% and 50%. But they're not, so you have to take a different approach. One way you can do it is just kind of read it. And realize that the boys make up 60% of the 42%, and the girls make up 40% of the 51%. Remember in math, the word of needs to multiply. So what you can do is do 60% times 42 and take 40% times 51. and then you add up those two values. When you do that, here's what you get. Notice here, 60% of 42 is 0.252. 40% of 51 is 0.204. You add them up and convert it to a percentage. You're going to get 45.6%. Be careful, it looks really similar to this one. These two numbers are in a different order. This is a different percentage. This would be the right answer. Now, if you're a visual learner, what you could do is actually make a tree of this information, and I'll show you how that would work. When you first set up a tree, what you would do is realize the first branch would be based on being a boy or a girl. So you would come in here and say boy or girl. Boys is 60% chance, girls are 40% chance. Now you'd want to see this thing branch off. For the boys, there's going to be the 5 different books. So if each branch is a book, we can just maybe say the Harry Potter, Animorphs, Lemony Snicket, Lord of the Rings, and others. And the girls, we're going to have the same 5 combinations. And the only one we're looking at for this case is Harry Potter. So I'm going to stick with this Harry Potter branch. Now for the boys, Harry Potter was 42%, so let's write that right here at 0.42. For the girls, their Harry Potter was at 51%. Now, the only branches we are interested in looking at is that the boys looked at Harry Potter and that the girls read Harry Potter. So I'm either want to have this branch or this branch. Remember, in probability theory, or means to add. So what I do is come up with the answer here and the answer here and add them up. What this string means, because it's just a string, is you are a boy and you read Harry Potter. Boy and Harry Potter, and is going to be to multiply. So 0.6 times 0.42 is going to get you the 0.252. For the girls, it's 40% times the 51%, which is going to get us the 0.204. And just like before, when you add these together, we're going to get 45.6%. It doesn't matter which method you use, either the algebraic formula or the tree for the branches, the same answer is appropriate. Keep this problem in mind when you look at the pizza questions for homework.